Sugar is one of the most popular substances that's produced in the world. We consume approximately 200 million tons of sugar every year, produced mostly in South America, India, and European Union. This is a European sugar beet. These grow everywhere where I live. There's literally millions and millions and millions of great big mountains when they get harvested. And this sugar beet contains approximately 15, maybe 20% sucrose. So this is an example of approximately how much sugar could be extracted from one sugar beet if it was 100% efficient. So what I'm going to do, I'm going to walk you through the entire process from sugar beet to as pure white crystals as I can make. I'm limited with home equipment how pure I can get it, because you need proper industrial equipment to get it properly filtered and clarified and turned into pure white sugar. But let's see what we can do at home with just home ingredients and home equipment. So the first stage of sugar production is to get this and peel it and cut it up into tiny little pieces, and then you heat it up in water to extract the sugar solution from the cells that are in here. So the first stage, I'm going to go through this. There's like 5 different stages. So as a summary of what's about to happen, first you process this into small pieces. You boil it, or not boil it, you heat it in hot water, not boiling water, to extract the sugar. You then filter it, strain it. Then you add acid and base and filter again through charcoal. And then you evaporate the water and you get the crystals of sugar left over and possibly some molasses residue as well. So we're going to process approximately 2-3 kilos of sugar beet and see how much sugar we actually get by the end of it. So stay tuned and see if we can get a good yield, maybe 10% if we're lucky, but we'll see. Let's go. Yeah, step 1, these beets are disgusting. So you're going to get them in the sink and we're going to give them a good scrubbing. Get as much of the mud and nasties off the outside as you can. One of the problems is that when you cut these, they're going to start to oxidize with the oxygen in the air. So as soon as they're peeled, they need to be kept underwater. Otherwise, the sugar will oxidize and go brown. And we're trying to make pure white sugar, so we're going to try and keep it as clean as possible. They look a little bit like parsnips, but they're not. Okay, so they're a little bit cleaner. Now we're going to fill the sink with cold water, and then we're going to peel them underwater to stop them going brown. Okay, tools of the trade. You need a big knife and a vegetable peeler. So I'm going to cut the end off, and I'm going to cut the top off. You can see inside it's kind of whitish, a little bit green on the outside. And then all you do is get your vegetable peeler and peel everything that's not white. When it is white as you can. The shape of them is a bit difficult to peel sometimes, so you might need to cut them a little bit. So we've got a bit of brown bit there, we don't want that, so we're going to cut that off. Still a bit brown. These didn't cost any money, they were free, so it doesn't matter if I waste a little bit of it. Take the green bits off as well. So now we've got more or less white piece. We're going to leave that underwater and then do the others. As you'll see through this process, sugar is a completely unnatural substance to have. It's purely man-made. It does not exist in nature. It exists inside here in nature, but in its pure crystalline form, it's a man-made product. The amount of work that is involved in this is insane. This is why it's done in a plant with machinery. To do this manually, it's not easy. Okay, next. So in order to calculate exactly how much sugar yield I'm going to get, I'm going to weigh how much raw sugar beet we've got here. Okay, so we got 1,180 grams. Okay, so let's see what we get. First job, we need to grind all this up. Okay, so you've got your cleaned and peeled sugar beets. Now I'm going to roughly cut them up a little bit, put them in the food processor. Okay, we're going to do this in 2 batches. This is distilled water. We're trying to keep this as pure as possible, so you can't use tap water. Add a little bit of water to help the food processor do its job. And you've got nice fine sugar beet pieces. Then we're going to put it into a saucepan with nice small bits. Yeah, a bit more water. Let's try not to waste any of this and rinse the inside with some more water. Try and be as efficient as we can and get the best yield possible. So that's approximately 1,150 grams of sugar beet. I'm going to add some more water. I'm going to save just a little bit of water for later for purifying. Okay, we're ready for the next stage, which is the extraction phase. We're going to now heat it up to approximately 75 degrees for about 2 hours and let all the cells burst and release their sugar into the water. But you don't want to heat it too much. You don't want to take it over 75 degrees, otherwise the pectin, the protein that's in here, will degrade and it will make it more like jam. And we don't want to make jam at this point because we're trying to extract the sugar. So let's go over to the cooker. So I'm going to stir this solution, get it up to 75 degrees approximately. I have an electric thermometer. Make sure that it's not overheating. So at the moment it's 17 degrees in here. So you want to do this for about 2 hours. So yeah, I'm not going to do the whole thing on here on video in 2 hours, but yeah, keep stirring it and keep it under 75 degrees for 2 hours, and then we'll go to the next stage of extraction. Okay, so we're now approximately 75 degrees Celsius. Smells like boiling plants. 73.5, 75. Okay, so now I'm going to move it over to the small ring, and I'm just going to let it sit there for about 2 hours approximately. Current time is 2:30, so 4:30. Well, we'll take this out and we'll start the next part of the process. We've made it to the next part. So this is the heated sugar pulp. It's not boiled. It went to about 75, 80 degrees, and it's now gone a slightly black color. So the next stage is we're going to filter this, remove all the pulp. So I've set up a multi-stage filtration system because if I pour it straight into the nut milk bag, then it's going to potentially clog the bag and be difficult to filter. So I'm going to use a large hole strainer and then a sieve, and then I'm going to put it through the nut bag when it's cooled down a little bit and doesn't burn my hands. Because at the moment it's a little bit hot. Very carefully, I'm going to pour mixture. Yeah, this is very hot, so I'm not going to push it with my hands. I'm going to use a glass jar. I'm just going to squeeze the pulp and get as much liquid out as I can. Here we got most of the liquid out. I could maybe get some more, but we don't have to be 100% efficient with this one. So we caught a little bit extra in this one. Let's recombine these. I might do a second pull depending on the amount that we get from this. Okay, so now we've got this black liquid. So this is citric acid. I'm going to add a teaspoon of citric acid. This is going to react with some of the impurities and the proteins that are in this black liquid. And then we're just going to gently simmer this solution to make that reaction with the impurities happen a little bit faster. And as that reaction goes, you'll see a foam start to appear. You can see a little bit of foam on the top now. As it starts to boil, there should be some more foam forming as the impurities start to coagulate. And now you can see a foam starting to form on top. This is some of the impurities that we don't want. You want to very carefully remove this foam. This is the most complicated way ever to make a cup of tea. Makes you really appreciate what goes into food production. Making sugar is an absolute mission. Okay, we've got most of the foamy bits off. Okay, so we're gently simmering, make it a little bit more foam production. Okay, I'm going to turn the heat off now and just let it settle for a minute and get the last of the foamy bits. Okay, I think this is good enough, as good as it's going to get from a home setup. Okay, the next stage, we've got sodium bicarbonate solution. It's a concentrated sodium carbonate solution. And now we're going to use this little syringe. So as I add this, it should fizz now, because this has the citric acid solution. So this is acidic and this is basic. So we're going to react the citric acid with the sodium bicarbonate, and we're going to make sodium citrate, carbon dioxide, and water. And the way we're going to test if the solution is at pH 7 is that as I add a drop, it fizzes. So what I'm going to do, this is kind of like a kitchen version of a titration. What we're going to do is try to neutralize the acid completely. As you can see, as I drop in the sodium bicarbonate, you get these little fizz puddles. And so we want to keep adding more until the fizzing stops. If I go a tiny little bit too far and add a little bit too much sodium carbonate, then it's okay. I just don't want it to be acidic. So I'm just going to do this really, really slowly. It might take a while. Definitely still fizzing. I would normally do this with a pH meter and measure the pH till it gets to 7, but unfortunately my pH meter is broken. So we're going old school. We're doing this visually. Every drop you see is fizzing. So this will take a little bit longer than it would if I was doing this with a pH meter, because I don't know what the pH is currently. I'm just guessing. It's definitely still fizzing. And a little bit more foam now, so let's take that foam off, otherwise we won't be able to see if it's fizzing. Okay, we're definitely still fizzing. Starting to get foamy again. You can see why they do this in a factory and not in the kitchen. Let's get these bubbles. Well, it looks like it's working because we're getting lots of foam coming off, which is all things that we don't want in our sugar. I think I put too much acid in here. It's going to intentionally take quite a lot of sodium carbonate. It definitely looks like it's fizzing less now. So maybe we're getting close. Fair play to the guy who figured out this process back in 1747. Okay, we're getting a little bit fizzing now, but not a huge amount. So I think we're fairly close to neutral. I think we're fairly close to neutral. I'm gonna just call it neutral now because this takes far too long. Okay, so let's do a final little stir, then get this foam off the top. Okay, we're ready for the next part of the process. So now we're going to add some activated charcoal, and that's going to bind to the impurities. This is hopefully going to take some of the darkness out of the liquid and turn it into a nice, clear, crystalline solution once we filter it. Okay, so I'm just going to stir this for a little while. Get more foam. We'll clear that foam off too. Aim of the game is to get the whitest sugar we can get from a home experiment. Okay, I'm going to leave this to settle for just a few minutes, and then we're going to filter it one last time. Okay, so we've made it to the final cleaning stage. So we've now acidified and then neutralized the solution to get impurities out. So now you're going to use a nut milk bag to filter out the larger particles of the carbon that's in here. And then we're going to do one last filter through coffee filters, which might take some time, so I might have to leave that overnight maybe. It might take a few hours. So let's see how long it takes. I'm going to set up a triple filtration system, so we're going to have 3 at the same time. We're going to have 2 with funnels and filter paper, and 1 with a sieve and a filter paper. So the theory goes that we should get it reasonably clear. So when it comes out, it'll be still slightly brown because this is not a perfect process. But I'm hoping that it will be reasonably clean. So let's see what we can get after we filter this solution. If I was doing this in a lab, I would use a bucket and a funnel with a vacuum pump, but I don't have one, so unfortunately this is going to take some time. If you like these sciencey videos and you want me to make some more chemistry stuff, then I can invest in some equipment, but that's going to cost a lot of money, and this channel is not yet monetized. So if you want to support my channel, then you can make donations. So what we're going to do is filter all of this liquid, and then we're going to use a vacuum chamber to evaporate the water without heating it too much, because I don't want the sucrose to degrade, because if you heat it too far, then the sucrose breaks up into its glucose fructose components and it becomes a syrup, high fructose corn syrup. We don't want corn syrup, we want crystals of sucrose. So this process means that you don't heat it if you use a vacuum. It's a vacuum chamber for evaporating water. I'll show you later. We'll get this filtration done first. Okay, so it's not clear liquid coming out, but it's still cleaner than it was. And it's going faster than it did earlier, so we're winning. As the filters clog up, they slow down a lot. Still going all right though. Let's see how well it filters on the first round. We might do a second round of carbon filtration if it's still too dark, but we'll see how it goes. Okay, well, it's all in the funnels. Let's give it half an hour or so and start the next part. Okay, we're nearly done. We've got a whole bottle here ready to go. It's a little bit dark still, but it's almost impossible to get it completely clear in a home setup like this. This one is nearly finished. There's a few drops still to go. And it's getting really late here now, so I'm not going to do the crystallization today because that's going to take another 6 hours or so. This is not efficient to make yourself a cup of tea, although this actually tastes really nice. So if you want a cup of tea, you could use this as a sweetener for tea as it is. What we're going to do is tomorrow I'm going to evaporate this using a vacuum evaporation system that I'm going to build today, and then we're going to do some crystallization, and with the leftover syrup I'm going to make some ice cream. So stay tuned and let's get to the next part tomorrow. We've made it to the second day of my sugar extraction experiment. So this is the beet juice that we made yesterday, but I didn't have my pH meter and I was trying to balance the pH manually by eye, and I didn't quite make it. I've now got my pH meter working, so we're going to do the neutralization first with the sodium bicarbonate, and then we're going to evaporate some of the liquid, and then we're going to make a more concentrated syrup, which we'll then use for the crystallization. So first we're going to put this beet juice into a pan, and then we're going to add sodium bicarbonate solution until we reach pH 7. So this is a electronic pH meter. It currently says 6.7 and it's in distilled water. It should be 7. So on the back it has a little calibration screw. This is not a very good pH meter. We're going to adjust the pH in the water. Okay, now it says pH 7. So we're going to try to get the solution to pH 7. So I'm going to use sodium bicarbonate. I'm going to dissolve that in distilled water. I'm going to heat up the juice. Okay, so let's do a starting pH test. Currently 5.2. Seems to be going down. Maybe it's reversed. 5.7, 5.8. Getting a lot of foam. 6. I'm getting there. 6.2, 6.6. Nearly there. As soon as we get to 7, we can take all this foam off. 6.8, 6.7, almost there. I think this will be it. 6.9. Okay, I'm happy at this. We're now at 6.97. Yay! Hopefully this is accurate. If not, well, there's not much I can do about it. Okay, so we're ready for the next stage. So as we did last time, I'm going to skim off this foam on the top, because that has some of the impurities that we don't want. Okay, it's good enough. Hey, I'm just going to warm this up a little bit till it's just about to start simmering. Normally, when you're doing this process, if you're doing it at home, you're going to just boil the liquid now until you evaporate off enough of the water to make a syrup. The problem with that is that sucrose degrades at high temperatures and it inverts and it becomes fructose and glucose molecules in a syrup form instead of crystalline sucrose. We want to try to maintain the sucrose crystals intact and grow them. So what we're going to do, instead of boiling it away on a heated source at 105 degrees where you risk inverting sugar, I'm going to put it to a vacuum chamber which will allow the water to boil off at a much lower temperature. So first we're going to heat it up to just about simmering level, and then I'm going to heat it just with candles on a little device which I've made over here. So I'm just going to heat this up and then we'll start the next part, the evaporation section. Let me show you this setup. Outside we've got the vacuum pump because it's going to make lots of smoke and that's not very pleasant. And here we've got the vacuum chamber. So we're going to pour the liquid into here, and then underneath we've got some candles, some little tea lights, which we're going to use just to very, very gently heat the liquid so it maintains about 40, 50 degrees, and which will enable it to boil without actually boiling. So we'll be able to get this water out much faster without inverting the sugar. Let's see if we can get a good angle so you can see what happens. Okay, so let's pour the sugar solution. Okay, very steamy. And now put the lid on the top. So if you've used a vacuum chamber before, you've got two valves. This valve goes to the vacuum pump and this valve closes the vacuum. So if I open this one, then air can go into here and it releases the vacuum. So I'm trying to make a vacuum, so I'm going to close this valve. If I want to control the vacuum, if the pressure is too high or too low, I can manually adjust this to change the pressure a little bit. Because if it boils too vigorously, then you want to reduce the vacuum. You won't be able to see what's going on very well inside here, but we'll see if we can get it started. You can see the vacuum is forming as the needle moves. You can't see inside because of the condensation. I'm not going to start the candles yet because it's still really hot. This process is probably going to take a couple of hours, so I'm not going to film the entire thing. So we'll come back and we'll check on this in a little while and see how we're getting on. There's the setup. So we've got the big tank. We've got the tea lights underneath for later when it gets a bit cooler. And the vacuum pressure sucking all the liquid out. You can't see the boiling inside because it's got too much condensation, but that's good because it means it's actually working. It's boiling away. So we're going to give this a couple of hours and see what happens. Okay, this has been running for quite some time now, but I've got no idea how much water has evaporated. So we're going to do a little test. I'm going to release the pressure and then measure the volume of the water and see if it's decreased much or any at all. I don't know if it's actually working or not. So very, very slowly turn this valve and the air goes in through here. Just do it very, very slowly so it doesn't explode in my face. Okay, let's have a look. You can see inside the sugar solution. So let's very carefully measure the volume, see what's inside. Okay, so if you remember before, this one was about here. So we haven't lost very much at all. Maybe this is not the best way to do it. It's slow, but I don't know. Should we speed it up a little bit? I don't want to be here for the rest of my life. Okay, we do have some reduction. I don't think my vacuum pump is powerful enough to get a good enough vacuum to make it efficient. So let's just see. I'll leave this for a few more hours. It's definitely decreased in volume a little bit, but not enough. So let's get it back under vacuum. Now we'll come back and check it in a little while. Okay, pressure is back. Let's come back a bit later. We've made it to day 3 of this epic challenge to make sugar. So far, we've managed to reduce the beet juice down to 700 mils. It was 1.2 liters. So we've reduced it by 500 mils, but it's not enough. We need to get it down to about 250-ish. So I'm going to put it back in the pressure cooker, in the vacuum chamber again. This time a smaller chamber, and also we're going to heat it a bit more intensely this time using the gas instead of the candles. So we'll put the beet juice in, the lid on. I'm going to put it on very, very low heat to start with, just to get it boiling. But I want to keep it under 100 degrees because otherwise the sucrose will degrade, will invert into fructose and glucose. We don't want that. We want to try and keep the sucrose as pure as we can. So I'm going to give this a few minutes to warm up. Then I'm going to turn on the vacuum and hopefully it will go a little bit quicker than it did yesterday. Because yesterday it was running for about 10 hours and only reduced by 500 mil, which is very, very inefficient. So let's see how we get on today. Let's get this pump going. And then close the valve. Okay, so we're going to come back to this in about an hour or so. I hope it's not longer than an hour. It's currently 2:15. So, no, 12:15. So let's get it boiling first and then turn the heat down and hope it works. Okay, let's see if we've got any reduction in liquid yet. We started with 700. We're now just over 500. Okay, so we've got about 50% more liquid to get rid of. We're getting there. We're down 700 mils in total. This low flame works quite well because it gets to 90 degrees and doesn't boil, but when you put the vacuum on, it does boil. So hopefully another 30 minutes or so, this should be ready. You won't be able to see through, but it's now boiling. Not sure if this is a very good thing to do to my vacuum pump, but yeah, it's a fun experiment anyway. If I kill my pump, worth it for the views. Please share and like and subscribe. If you find this experiment interesting, knowing where your sugar comes from and how difficult it is to make sugar without a giant factory, it's really, really hard. So I'm going to give this another 20-30 minutes, and then we'll come back and check. So we're now down to about 350 milliliters. It's starting to get quite dark and much thicker now. About 100 more milliliters to go, and then we will go on to crystallization. So we're about an hour away from seeing if this experiment actually works and we get some actual crystals or just a pile of black syrup. But stay tuned and let's find out what we get. And here we go. We're at the final stage. We've now got syrup, which is very hot. So I'm going to stir this a little bit. It's now about 200 mils. So from 1,200 mils down to 200 mils. And now what we're going to do is grow some crystals. So this is now a super saturated solution of sucrose. So when you add little seed crystals, we're going to add some pure white crystal sugar. We're going to use this as seeds to grow more sugar. It acts as a template, and then the sugar that's dissolved in here knows how to build itself into little structures. So we're going to cool this down gently and pouring it into a big flat tray. It's sticky now. And just gently agitate. Zoom in a little bit, see if we can actually see the crystallization happen. Okay, so I'm going to very, very gently sprinkle seed crystals. Hopefully they don't just dissolve. Maybe it's too hot still. We're about 38, 40 degrees. Okay, let's just dump in these seeds and see if anything happens. Do we get crystals, or do we just end up with a big black mess? And the big question, does it taste nice? Let's see. Little sugar crystals. Definitely got some crystals forming in the bottom. So as this gently cools down, crystals should grow. Fingers crossed. It's a really, really long experiment. I want at least 1 teaspoon of sugar. More than the teaspoon I just added. Okay, so I've added a fan just to keep the air moving across the top to assist further evaporation of any leftover water. And hopefully that will very slowly crystallize the sugar. We shall wait and see. Stay tuned.